Hello 9th standard students. This is the concluding video of exercise 7.1. In this video, I have done question number 8, which is a very important question from exercise 7.1 and it is generally asked for 4 marks. Also at the end, some important concepts from this chapter are given which I want you to remember. Let's have a look. So question number 8 from exercise 7.1. It is mentioned that in this right angle triangle ACB, C is 90 degree and M is the midpoint of seg AB. So it is shown by this indication that AM is congruent to BM. At the same time, I've highlighted this. DM is congruent to CM by these two lines. And these are the 4 things that you need to prove in this question. So what we will do is one by one we are going to prove them in different parts. So I will take this as part 1. I've taken this as part 2, part 3 and part 4. So let us mention first what all is given. It is given that angle C is 90 degree and M is the midpoint of AB and the meaning of that is AM congruent to BM and I've numbered that as 1. Also DM congruent to CM which I've numbered as 2. It is not necessary to number them out here. Okay. To prove, this is the first part. Let us look at the proof. To prove triangle AMC congruent triangle BMD. So I have taken these two triangles separately. So I've taken these two triangles and in order to prove them congruent, first let's look at the indications that have been given. So we begin the proof by writing the name of the triangle and what all is given. AM congruent to BM shown by this indication in blue. Then look at these two angles. They are congruent because they are vertically opposite angles. So I draw these two angles and mention it out here that these angles are congruent because they are vertically opposite angles. And then the third one, CM equal to DM, it is given. Therefore, the two triangles are congruent by SAS congruence rule. Mention the test of congruency. Now let us write down the corresponding parts of congruent triangles. Now students, how do you remember or how do you know which are the corresponding so now students, how would you know which corresponding part to write? In this very proof, you know that there are 4 parts to it. So now you have to look at the second question or the second part. On that basis, you will write the corresponding sides or the corresponding angles. What I have taken out here is, I have mentioned AC is congruent to BD because you will require this in one of the proof. And at the same time, angle ACM, that is this angle, is congruent to angle BDM. Look at the corresponding parts. ACM will be congruent to BDM because of CPCT. That means this angle here and this angle here. Now, if you look at the shape, isn't it Z-shape angles? That is the angle out here and angle out here. So they are alternate angles, right? And if they are alternate angles, then the two lines, that is AC and BD, or you could say the two segments, they become parallel because of converse of alternate angle theorem. Because you have learned that when a transversal intersects two lines, and if a pair of alternate angles are congruent, then the lines become parallel. So please make a note of this. We have proved AC parallel to BD. Now, why is it that you have to prove them parallel? They have not asked you to prove them parallel. Because the next part is you have to prove DBC is 90 degree. So in order to prove it is 90 degree, we need to prove these two parallel. Let us see why and how. Second part, to prove DBC is a right angle. Now look at the figure. I have taken DBC. You have to prove this B is 90 degree, but in the question it is given that C is already 90. Now what we have done, we have proved AC parallel to DB in part 1, right? If AC becomes parallel to DB and you take BC as the transversal, so you have taken BC as a transversal, then don't these two angles become pair of interior angles? So if this is 90, what will be DBC? DBC will also become 90. So have a look. You know that AC is parallel to BD because of converse of alternate angle theorem. Taking BC as the transversal, you get ACB equal to DBC equal to 180 degree. Okay, so we have proved that DBC is a right angle. How so? Can you solve this further? Yes, we know the value that ACB is 90, DBC is not known to us. So with that, DBC is equal to 90 degree. So we have proved B is a right angle. Now this is the third part. In the third part, you have to prove triangle DBC is congruent to triangle ACB. So again, I have taken the triangle separately. See, for each time I take these parts, you don't have to draw it separately. This I have kept it for better understanding, and on the basis of this, I have drawn the diagram. Okay, so that it is clear when I explain. Now, prove DBC congruent to ACB. Now look at these indications. Where suddenly these indications came from? If you look at the first part, in the first part we had proved AC congruent to DB, right? In the second part we proved this angle 90 degree. That is why I have put these indications. So take the two triangles and then you know DB equal to AC from 2, see part 1. Then these two angles are 90. That also we proved from part 2. And BC equal to CB common side. So the two triangles become congruent by SAS because this is a common side. So SAS congruence rho. So hence we have proved it. Now we will move to part 4. But before we move to part 4, again you have to write one CPCT because you will require this in the next part. Now if the two triangles are congruent, therefore BC becomes congruent to AB. Because in the fourth part you have to prove that CM is half of AB. So we require this AB. So write down the CPCT, BC congruent to AB. Students, what you realize in this question is for every part there is a CPCT, and that CPCT of the first part you're using in the second part. The CPCT of the second one you're using in the third. The CPCT of the third you're going to use in the fourth part. Let us have a look. Now this is the fourth part. You have to prove CM equal to half of AB. So let's start with the proof. What we did in the earlier part, we proved triangle DBC congruent to triangle ACB, and we also proved BC congruent to AB in the earlier part. So we are making a note of that. This is the CPCT from part 3. Okay. Now, since you need half AB, what I'm going to do out here is I'm going to divide both the sides by 2 or multiply both sides by half. So I divide both sides by 2, so I get half DC equal to half AB. Now, half DC. Look at DC. Isn't M the midpoint of DC? It is already given. Under given, you have dm congruent to cm. So half of dc is cm. So instead of half dc, I will write cm. So cm is equal to half ab. I keep it as it is. And this is what you had to do. So hence proved. So students, these are the 4 parts to this question. You don't have to draw a separate diagram in each and every part. Just draw the first diagram which is there in the question, and then you can write it in the form of different parts. Okay, please go through this proof. This is a very, very important proof from this exercise. And so with this, we end exercise 7.1 out here. Take care and thank you.